So here are some extra problems for section 8.6 to kind of help you out with the homework. First one I did is number 8 here. I'm going to do is number 8. So 8 says find the slope of a snowboarding beginner hill that decreases 24 feet vertically for every 30-foot horizontal increase. So the thing about slope is the definition that the book gives us is rise over run. So the vertical is the rise, horizontal is the run. That's the definition of it. Now, the one thing they do though is they tell us it decreases 24 feet vertically, which means it has to go down 24 feet, which means it's a negative 24-foot rise. And then it's going to go a 30-foot horizontal increase, which means that's going to be positive, so plus 30 feet. And then that reduces to, divided both by 6, negative 4 over 5. That's our slope. Okay. So if I think of this like, as a ski slope, here it is. I've gone down 24 feet as I've gone 30 feet. Another way I can think of it is, oh, you're going to go down 4 feet every time you go over 5. Down 4 feet over 5. Down 4 feet over 5. Down 4 feet over 5. That's what's happening. So that's how it works. Down 4 over 5, down 4 over 5, down 4 over 5, down 4 over 5. Well, if I look at that, 4, 8, 12, 16. Oh, I meant to go one more. Whoops. 20, 24. I didn't do enough triangles. And then over 5, 10, 15, 20, 25, 30. Okay. The next problem is the same thing. Find slope again. But this time we're doing it from the visual representation itself. Okay. So I always do this I always think of slope as movement from left to right visually. I read it like I read a book. We read from left to right. So we can see this guy's going up as I go left to right. If I think it's like traveling along a left path to this, it's going up. So I know my slope should be then positive because the graph is increasing. Remember, slope is just another thing of rate of change, just the graphical version of it. Well, now I got to figure out how much did it do that. Well, let's see here. I started down here. Now I'm up here, so I had to go up 2 to do that. So it's a positive 2, just to get on the same level as this guy. And then he moves over plus 6 to get from here to here. So slope is a rise of 2 over a run of 6 that reduces to 1/3 because it's a positive rise and a positive run. Now, if I look at this though in the graph, notice it was 1/3. I have 2 over 6. That's because there's a point right here they didn't label for us that we could also think of having gone up 1, right 3, up 1, right 3. So I also get that triangle. Okay. All right, so that's 1/3. Now the last one that the book throws at us for this is that I want to look at is finding it from 2 points. Now the book does have a formula for this. It's called the slope formula. And slope, denoted with the letter M, is y2 minus y1 over x2 minus x1. Which, if you think back to when we did the rate of change, was always subtract 2 of them and divided by 2 of them subtracted. It's the same thing. The difference is you got to make a choice as to which one of these is x2, y2, and x1, y1. And it doesn't matter. A lot of people like to just do it like this, where they just call the first point x1, y1, and the second point x2, y2. Okay. And all we do is we subtract the y's. So if I do 6 on top, that's what I called y2, minus negative 6 on bottom, that's y1. It's going to be x2, which is 9, minus the other x, which is 5. That gives me positive 12 over 4, which reduces to 3. Now, sometimes people are like, well, what if I choose the wrong order? Well, it actually doesn't matter. If I make this y2, this means this is x2. So let me mark those out. This is y2, this is x2. This is y1, this is x1 then. I would have negative 6 minus 6 over 5 minus 9. Okay. So negative 6 minus 6 is negative 12. Okay. 5 minus 9 is negative 4. Oh, negative 12 or negative 4 reduces still to positive 3. So you don't have to worry about, did I choose the right order? No, as long as this is the y that went first and this is the x that went first, you're good. Or if this is the y that went first, that's the x that goes first. You're still good. Okay, that's section 8.6. I think what we're doing here.